This is Algebra 1 spring test for week 10 study guide. Number 1 says write the polynomial in standard form, then name it based on its degree and number of terms. Remember, standard form has the largest exponent first, then it counts down to the smaller one, then the next smaller one, and so on and so forth. So this first one says 2 minus 11x squared minus 8x plus 6x squared. First off, this one's unlike some of the examples we looked at because there's two of them that you need to combine here because there's two x squareds. So we can combine those two. Negative 11 and positive 6 is negative 5x squared. The next biggest degree is the x to the first power, negative 8x, and then positive 2 is last. Now it's in standard form. So it says then name it based on its degree. We know that it's whatever this is, so it would be the second degree. And then name it based on how many terms it has. It has one term, two terms, three terms, so we'd call this a trinomial. So when you see that nomial part, you don't freak out. We've been just abbreviating it as tri. Don't count them right away and say, well, there's four of them. It's got to be a polynomial. No, you can combine those two x squareds to make it a trinomial. If I asked you also for the leading coefficient of this one, you'd say negative 5 is the leading coefficient. That was not part of the question, though, for this one. So it's a second degree trinomial. Number 2 says write the polynomial in standard form. Remember, in order to be standard form, the largest exponent is first, then it counts down. Your largest exponent is the third power. So negative g to the third plus 3g squared. The next biggest exponent is g to the first power. It's positive 4g, followed by the thing that has no variable, the constant, negative 2. Now it's in standard form, 3, 2, 1, no variable. Number 3 says find the degree of the monomial. Remember, the degree is the largest exponent that's represented. So it's m to the 6th power. So this is a 6th degree monomial. Simplify the difference for these two. You can use either the horizontal or the vertical method. We'll show both. The largest degree is negative 5x to the 4th minus negative 7x to the 4th. Negative 5 minus a negative means plus a positive. Negative 5 plus 7 is positive 2x to the 4th power. The next one, the next biggest degree is x to the first power. Negative 7x minus a negative 5, I'm sorry, not 5, negative 7x minus a negative 9x. Minus a negative means plus. Negative 7 plus 9 is positive 2x. And then the last one is the constant 5 minus a negative 5, which means 5 plus 5 plus 10. That's the horizontal method. The vertical method is when you stack the like ones on top of each other. Again, since it says minus in the middle, all of the signs in the second one are going to change. So instead of positive 2w squared, negative 2w squared. Instead of positive 3w, negative 3w. Instead of negative 6, positive 6. So now just combine those. 4w squared and negative 2w squared is 2w squared. Negative 4w and negative 3w is negative 7w. And negative 8 and positive 6 is negative 2. Again, that's the horizontal and the vertical method. Number 6 is simplifying the sum. So you don't have to change the signs for this one. You're just adding them together. Remember, you're adding the ones that have like terms. Like terms are the exact same variable to the exact same exponent. The biggest degree is the third power, 4u to the third, plus 6u to the third. 4 plus 6 is 10u to the third. The next biggest degree is 4u squared. So you have squared next. So that's the only one. There's no u squared on the right. So we'll simply write plus 4u squared. The next biggest degree is u to the first power. Notice there's no u to the first power on the left. There's just negative 2u to the first power on the right. So we'll simply write it as negative 2u. Now check, we're adding these right here. So we're going to put whatever sign it says, negative, but had it said minus in the middle, we would reverse that and make it say the opposite, but it doesn't. And then finally, your constant terms, 2 plus 8, which is 10, positive 10. And there's your polynomial combined. Negative 7 is find the solution to the system of equations. Okay. This one is set up. Remember, we learned 3 different methods to solve systems. We could graph both equations. We could graph both of them on the same plane. We could estimate where that intersection point is, and then we could plug it in. That's the least effective method because there's a little guesswork involved, or we might make a mistake when we draw a line the farther away it is. Then we learned 2 methods, the substitution method and we learned the elimination method. This one is set up better for the elimination method because they're stacked nice and neat on top of each other, and you don't have any variables isolated or by themselves already. But we don't have opposites. 2 is not the opposite of negative 5. 5 is not the opposite of 3. So we can either choose to make our x's into opposites, which will be easier, or our y's into opposites, but neither one of them would be exceptionally difficult. The smallest number that both 2 and negative 5 go into is the number 10. So in order to create 10x here, we need to multiply that whole equation by 5. 5 times 2x is 10x. 5 times 5y is 25y. And 5 times negative 4 is negative 20. So notice we multiplied the entire equation by 5. Again, we want to make that negative 5x into negative 10x. So multiply this entire equation by 2. 2 times negative 5x is negative 10x. That's the one we wanted to get we wanted to make those opposites. But we can't just multiply that one. We got to multiply it by 3y, which is 6y, and we got to multiply it by 10, which is 20. So now we have opposites stacked on top of each other. Now draw yourself a line here to where you don't look at the equations above, and a line here knowing to combine these two. 10x and negative 10x is no more x's. 25y and 6y is 31y. And negative 20 and positive 20 is 0. So now we can solve for y. Divide by 31 on both sides. 0 divided by anything is 0. Now you have a value for y. That's not the answer to the system of equations, though. Remember, a system is a point. In order for it to be a point, you need an x and a y coordinate. Plug 0 into one of the other equations. They look the same, so plug it in to the first equation to where you don't make a mistake. 2 times x plus 5 times our new value for y equals negative 4. Our new value for y is 0. 5 times 0 or anything times 0 is 0. What that does is it eliminates itself and leaves you with 2x equals negative 4. Divide by 2 on both sides to get x alone, and x equals negative 2. Now you have an x and a y value written as an ordered pair. The answer to this solution, or the solution to this system, would be negative 2, 0. That is the answer to the problem. Number 8 says, what's the solution to this system? Now, this system is set up more for the substitution method. Substitution works easier if you write them next to each other. 4x plus 3 and y equals 5x minus 10. This says y equals this expression. So in place of y, we can plug in 4 plus 3, or we can substitute it in. Equals 5x minus 10. You have x's on both sides, so bring the smaller 4x over to the larger 5x side by subtracting it. If you subtract it on the left, do so on the right. 5x minus 4x is 1x. You still have minus 10. You still have equals 3 on the left side. Undo minus 10 by adding it to both sides. And 3 plus 10 is 13. So x's value is 13. Take that new value for x and substitute it back in or plug it back in place of x. So y equals 4 times our new value for x plus 3, and our new value is 13. 4 times 13 or 4 times 3 we know is 12. Carry a 1. 4 times 1 is 4 plus 1 is 52 plus 3. Y equals 52 plus 3, or y equals 55. So now we have a value for x and a value for y. X comma y is how you write a solution to a system of equations. 13 comma 55. There is the answer to the system. Number 9 says the sum of two numbers is 71. Their difference is 19. Write a system that describes it and then solve by elimination. Well, you have to know what sum means. You don't know what either number is. So here's one thing you don't know what it is, x. Here's another thing you don't know what it is, y. The sum means to add them together. It says their sum is 71. Then it says their difference is 19. Again, same x minus the same y. Minus, because it's the difference, is 19. Now this is set up, it says to use elimination, but this is set up nice and neat for elimination because we know what all these coefficients are. This is 1, this is 1, this is 1, and this is negative 1. So we have opposites, 1 and negative 1. So when we combine 1x and 1x, we're left with 2x. When we combine 1y and negative 1y, they're eliminated. That's what we wanted to do. And when we combine 71 and 19, we have 90. 2x equals 90. Divide by 2 on both sides, and x's value is 45. So now you have one of the numbers, 45. Plug it back into one of the equations. It doesn't matter which one because they're the same as far as difficulty goes. Plug it into the first one. X plus y, x is now 45 plus y equals 71. So that's our new value for x, 45. So get y by itself here. It's a simple equation. Subtract 45 on both sides. And y equals, we got to borrow one, 11 minus 5 is 6. 6 minus 4 is 2. So y's value is 26. So one of the numbers is 45 and the other is 26. So if you graph these two, the ordered pair where they would come out at is x comma y, 45, 26. But since this is a word problem and is asking you for what the two numbers are, one of them is 45 and the other is 26. Number 10 says solve this one using elimination. This one's set up nice and neat for you. X is on top of x, y is on top of y's, constants on top of constants, and 5 and negative 5 are opposites. That's beautiful. 2x combined with 1x is 3x. 5y combined with negative 5y is no more y's. And then 12 combined with negative 24 is negative 12. 3x equals negative 12. Divide by 3 to get it by itself. A negative divided by positive is a negative. 12 divided by 3 is 4. X's value is negative 4. Substitute that back into one of the other equations. 2 times x plus 5 times y equals 12. X is now negative 4. 2 times negative 4 is negative 8. Plus 5y equals 12. Undo minus 8 by adding it to both sides. Because remember, you undo addition and subtraction. You work your order of operations backwards before multiplication and division. 5y is equal to 20. And get y by itself by dividing by 5 on both sides. Y equals 4. Again, written as an ordered pair, x comma y is a solution. X is negative 4, y is 4. There is your solution to your system of equations. Number 11 and 12, solve these using substitution. We'll go a little bit quicker through this one. Here's your y's value. So in place of y right here, 3x plus 4 equals 2x plus 7. Bring your 2x over by subtracting it. Minus 2x on both sides will leave you with 1x. Plus 4 equals 7. Subtract 4 on both sides, and x equals 3. There's your x value. Substitute it back in to one of the other equations. Y equals 3 times x plus 4, or 3 times our new value, which is 3. Y equals 3 times 3, 9 plus 4. Y equals 13. X comma y, 3, 13 is your solution to the system. And 12 is even easier because since this one only has a monomial following it, 5x, in place of y, you can plug in 5x equals 4x plus 3. Subtract 4x on both sides to get the x's on the same side. 5x minus 4x is 1x is equal to 3. X's value is 3. Plug that back into the easier looking version, y equals 5 times x, or y equals 5 times 3. Y's value is 15. We have x's value already. The solution, x comma y, 3, 15 is your solution.